Hello everyone, how are you all? So, second video of states of matter, that is gas laws. Now complete gas laws we are going to see here. So we have four gas laws: Boyle's law, Charles' law, Avogadro's law and Gay-Lussac's law. So what are the gas laws we have and what are the related problems? Those all we are going to discuss in this chapter, states of matter, which is very important, and in that gas laws are very important. So let's get into this gas laws. Those who not subscribed, please do subscribe. Upper chemistry classes. So for complete chapter wise videos, now let's get into the video. So in that first we have the gas laws. We have in the last video, those who not watched the last video, you can see in the description, and also remaining chapters videos also I will mention in the description also, as well as in the iCard also I will mention. So try to listen here, the gas laws. So we have total of four measurable parameters: pressure, volume, temperature and number of moles. By keeping any two measurable parameters of the gases, so we'll give the relation between any two gases. Okay, so first we will get the PV law, that is what we are calling Boyle's law. So VT law, next one, that is Charles' law. Next one is we are going to get, so here pressure versus temperature, that is Gay-Lussac's law. It is also called Charles' second law. Next one is volume versus number of moles. Those are the four gas laws we have. So first we are going to see the PV law. So it is also called Boyle's law. There is no Gall's law. Okay, we have only Boyle's law. So that is PV law. PV law. So what is PV law here? So how we can define this Boyle's law means at constant temperature. What we have to keep here? Constant temperature of a given mass of a gas. Constant temperature of a given mass of a gas. That is, mass is also constant. So temperature is constant as well as of a given mass of a gas. Given mass of a gas. That is nothing but number of moles of a gas is also remains constant. The both constant temperature and given mass of a gas, both are constant here. So how we can define at a constant temperature, given mass of a gas whose volume is inversely proportional to pressure. Volume is inversely proportional to pressure. We should not say here volume is inversely proportional to 1 by P. We have to say volume is inversely proportional to P. If you are saying that volume is inversely proportional to 1 by P means it is 1 by P, it becomes what? Directly proportional. That is not the correct way of saying. You can say in another way also, volume is directly proportional to 1 by P. Okay, so that is the correct way of saying. So volume is directly proportional to 1 by P, or volume is inversely proportional to pressure. Now if I am removing this proportionality constant, then I am going to keep the one constant, that is K into 1 by P. So from this, PV is equal to constant K. K is constant. So now in this case what happens? K is constant. PV is equal to constant it is. Now it is the value of pressure and volume, product of pressure and volume will be remains constant. Now what happens actually, you see. Say for example, if pressure is increased, then what happens? Volume will be decreases. So then it will be remains constant or not? Similarly, if volume is increased, pressure will be what happens? Decreases. The resultant value will remains constant or not? So that is PV is equal to constant. So for first gas, pressure will be P1. For first gas, volume is V1. It is equal to K, constant. For second gas, pressure is equal to P2. Volume is V2. It is also constant. Then what happens? P1 V1 is equal to P2 V2. This is the formula to give the relation between pressure and volume. Okay, is that clear? Now we are going to take the here P is equal to K into, V is equal to K into 1 by P. Now you plot the graph between volume versus 1 by P. That is, it is in the form of Y is equal to mx. Now when you are plotting on Y axis, you are taking the volume, on x axis you are taking 1 by P. Y is equal to mx curves How you are going to get? Passing through the origin, which are passing through the origin at different temperature. Say for example, it is T1 temperature, T2 temperature, T3 temperature, like that. Is that clear? So how you are going to give that relation between T1, T2, T3 is very important. So I will explain. So how to give that relation also. Okay, na? So I will explain after discussion of this complete gas laws. Is that clear? So V versus 1 by P, we are going to get like this. So if I am plotting the graph between volume versus P, so if I am taking the pressure on x-axis, volume on y-axis, then we are going to get the curves like this. So that is exponentially it will be decreases. So at very high volume, the pressure is very less. At low pressure, volume is very high. So as pressure increases, volume what happens? Slowly decreases. Exponentially it will decrease. Okay, na? So is that clear? So here volume is inversely proportional to 1 by P indicates volume increases by 2 times, means pressure is also decreases by 2 times. It is not means that. So volume increases as well as pressure decreases, but not what we can say, it is not that same quantity. So how many times it will be increases, that much quantity will be decreases by pressure. It not means that. So volume is inversely proportional to pressure. Is that clear? You can take any different example. Okay, na? So if you fill the balloon, so when you are compressing, then what happens? When you are compressing, when you are applying the pressure, volume of the gas will be decreases. That is, gases will comes closer. The volume will be decreases. Okay. So you apply the logarithm on both sides for this equation only. Log V is equal to log K into 1 by P. So it is log A into B form. So you separate into log A plus log B. So that is log K plus log 1 by P. So 1 by P can be written as log of P power minus 1. So it is log V. So from this log V is equal to this P power minus 1, log of x power n form it is, that n you take in front, that is minus 1 into log P. This plus log K I will write here, plus log K. Now in this case what happens, how it is, y is equal to mx plus c form it is. Now y is equal to mx plus c form, curves how you are going to get? So we are going to get the curves. So by making some intercept with the y-axis, we are going to get the curves. Now what are the, on y-axis what I am going to take here? What I am going to take? Log V. On y-axis I am going to take log V. On x-axis what I am taking? Log P. So it is a negative slope. Negative slope in the sense we are going to get downward direction like this. Now this is intercept C. C is equal to log K. Now here it is what? Slope. Now the slope m is equal to how much here? Negative. So how you are going to get the slope? So y2 minus y1 by x2 minus x1 if you are doing, then you are going to get the slope. So how you are going to calculate the slope here? Slope is equal to, slope m is equal to y2 minus y1 by x2 minus x1. So this is y2, this is y1, here it is x1, it is x2. y2 minus y1 by x2 minus x1 if you do, then you are going to get the slope. Is that clear? So that is what graphs which are related to pressure versus volume. Now whatever the graphs which I am getting here, these all graphs are obtained at constant temperature. Say for example it is at T1 temperature, T2, T3. So at constant temperature, whatever the graphs which I am getting, those graphs are said to be isotherms. These graphs are said to be isotherms. The term is very important. So what is meant by iso here? Same. Therm means temperature. Same temperature. The graphs which are plotted between the pressure and volume axis, between pressure and volume, at constant temperature, they are defined as isotherms. Is that clear? Next we will see the another graph for this PV is equal to nRT. Just now we had seen, no? Boyles law, PV is equal to K. It is constant. So you are plotting the graph between product of pressure and volume, versus pressure or volume. So when you are taking on y-axis, the product of P and V, that is pressure and volume, will be remains constant. So whether you are taking the versus pressure or volume, if you are increasing pressure, volume will be decreases. If you are increasing volume, pressure will be decreases. That value will be remains constant. That is about what Boyle's law. It is takes place at constant temperature. Once again, I am defining the Boyle's law. So Boyle's law is nothing but what? At constant temperature, the given mass of a gas whose volume is inversely proportional to pressure. That is Boyle's law. Next is Charles' law. Charles' law. So what is Charles' law here? So Charles' law is said to be what? PV law is completed. We are going to see the VT law. So VT law. So volume to temperature law. Now in this case what happens? Volume is directly proportional to temperature. Volume is directly proportional to temperature at constant pressure. At constant pressure and the number of moles of a gas. That is, pressure and the number of moles of a gas remains constant. Now here volume is directly proportional to temperature. As volume increases, temperature increases. So why volume increases and temperature by increase in temperature, volume of a gas is also increases. Because when you are increasing the temperature, whatever the forces, weak van der Waals forces which are present between the gas molecule will be break down by the temperature. So the gas molecule gets the more kinetic energy, they will expand. By that expansion, volume is also increases. So from this V is equal to K into T. So from that V by T is equal to K. That is constant. V by T is equal to K, that is constant it is. Now from this V by T is equal to K, constant. Now from this what happens if you are taking first gas V1 by T1, constant. For second gas, volume is V2, temperature is T2. That is V1 by T1 is equal to V2 by T2, which is also written as V1 by V2 is equal to T1 by T2. So that is directly proportional here. So we can define in another way also, Charles' law. So how you are going to define this Charles' law means, for every 1 degree, that is for every T degrees Celsius, the volume, initial volume is V0. For every T degrees rise in temperature, it is what? At 0 degrees Celsius, volume is V0. At T degrees Celsius, the volume of the gas is Vt. So for every 10 degrees rise in, for every T degrees rise in temperature, the initial volume will be increased by 1 by 273 times. Initial volume is increased by 1 by 273 times. Okay, na? So that is Vt is equal to V0 into 1 plus T by 273. Okay. So now this is called what? Vt is equal to V0 into 1 plus T by 273 times it will be increases. That is, initial volume will be increased by T by 273 times. That is 1 by 273 times for every T degrees rise in temperature. So from this what happens if you are taking 273 plus T degrees Celsius, which is nothing but T1 temperature. So similarly at T2 temperature, you can take the volume will be what happens? 1 by 273. 273 plus T1 it is, 273 plus T2 it is. So both you will take and the ratio you will get the V1 by V2 is equal to T1 by T2. Same you will get. So you can take at T1 temperature, at T1 temperature is equal to V0 into 273 plus T1 degree Celsius by 273. So you can take similarly T2 is equal to V0 into 273 plus T2 temperature by 273. If you are taking these two ratio, it is nothing but 273 plus T1 is nothing but capital T1. So it is nothing but capital T2. That is volume of T1, that is V1, it is V2 is equal to T1 by T2 if you are taking both the ratios. Is that clear? So that is what we are calling Charles' law. Now in the Charles' law, what are the graphs we are getting? Those graphs are said to be isobars. Those graphs are said to be isobars here. We will plot a graph here. So the graphs which are plotted between volume versus temperature. Volume versus temperature at constant pressure. At constant pressure is said to be what? Bars, isobars. These graphs are said to be isobars at constant pressure. This is what P1, P2, P3. Now what is the relation between that P1, P2, P3? I am going to tell you. So this is volume and temperature on x-axis. Now it is we are getting passing through the origin. What is the reason here? V is equal to K into T. It is Y is equal to mx form it is. Y is equal to mx form means it passing through the origin. If I am taking the what V by T on y-axis and temperature on x-axis, the V by T value will be remains constant or not? So it is what V by T is always constant by changing volume. So temperature is also increases. By decrease in volume, temperature is also decreases. Then what happens? The resultant value will be remains constant. V by T is always remains constant. Is that clear? Now we have V is equal to K into T. No? So for this V is equal to K into T, apply the logarithm on both sides. Log V, apply the log A into B form, that is log A plus log B, that is log T plus log K. So in this case 1 into log T, so Y is equal to mx plus C it is. Now when you are plotting the graph between y-axis, that is on y-axis we are taking log V, on x-axis we are taking log T. Now here with positive slope it is, positive slope we are going to get like this graphs. So with by making some intercept, that is C is equal to log K. Here it is a slope. What is the slope value here? Slope is equal to m, that is equal to 1. Is that clear? So that is the relation and graphs which we are getting at constant pressure. Those graphs are said to be isobars. Is that clear? Charles' law, the definitions. So next we are going to see the Charles' second law, or it is also called Gay-Lussac's law. So what a name it is, Gay-Lussac's law. So funny name. So you see the Gay-Lussac's law, Gay-Lussac's law. So Gay-Lussac's law, it is also called Charles' second law. Charles' second law. Gay-Lussac's law or Charles' second law. According to this law, at constant volume and given mass of a gas, that is number of moles is also constant. At constant volume and number of moles, the pressure of the gas is directly proportional to temperature. So from this P is equal to K into T, from this P by T is equal to K, that is remains constant. So from this what happens? Now P1 by V1, P1 by T1 is equal to P2 by T2. So that is P1 by P2 is equal to T1 by T2. Now by using this relation, we can give the what number of problems we can do based on the pressure and temperature relation. Is that clear? So next we are going to see the next one. So that is here pressure versus temperature. Pressure is directly proportional to temperature. Here whatever the graphs which we are getting, these graphs are at constant volume. So the graphs which are obtaining at constant volume, those graphs are said to be isocores. What they are called? Isocores. Now isobars in the sense the graphs which are plotted between the volume versus temperature at constant pressure, they are said to be what? Isobars. Bar in the sense what? Pressure. Bar is the unit of pressure. Now isocores. Course is what? Iso is same volume containing at same volume whatever the curves which we are getting, those are said to be what? Isocores here. Now you can take the pressure versus pressure is equal to K into T. So from this log P is equal to, apply the logarithm and divide into log A plus log B. So log T plus log K. So here also it is Y is equal to mx plus C form it is. So this is M, this is X. Now when you are plotting the graph between log P versus log T, so we are getting the water with positive slope. So it is a intercept C is equal to log K. Now it is slope is how much here? 1. Okay. So now you can take the P by T value, P by T on y-axis. If you are taking pressure or temperature on x-axis, so whatever the value you are changing, pressure or temperature, but P by T value will be remains constant. So that is Charles' second law or Gay-Lussac's law. Okay, whatever the graphs which you are getting, those graphs are said to be what? Isochores. I think so you have got it. Next we are going to see the fourth gas law. Fourth gas law, which is very important one. Fourth gas law, that is you can take it as Avogadro's law. Avogadro's law. What is Avogadro's law? What is Avogadro's law? Now here, at constant temperature and pressure, at constant temperature and pressure, volume of a given mass of a gas is directly proportional to number of molecules or number of moles. That is, at constant temperature and pressure, volume of a gas is directly proportional to number of moles. That is, we can define in another way also. At standard temperature and pressure, the equal volume of gases contain equal number of molecules. Equal volume of gases contain equal number of molecules. So from this V is equal to K into N. So from this V by N is equal to K, that is nothing but constant. It is K is what here? Proportionality constant. So from this V1 by N1 is equal to V2 by N2. So from this only we can get the V1 by V2 is equal to N1 by N2. That is, volume is directly proportional to number of moles. You can plot a graph between volume versus number of moles. It is directly proportional like this. Okay, na? So we are getting graphs like that. So V by N value will be remains constant always. Now in this case, here equal volume of all gases contain equal number of molecules. Say for example, that is 1 gram of hydrogen gas. 1 gram of hydrogen gas occupy how much volume it is? 11.2 liter. 11.2 liter of at STP. At STP, 1 gram of hydrogen will occupy how much? 11.2 liter. 1 gram of hydrogen is nothing but half mole of hydrogen. 2 gram is nothing but what? 1 gram molecular weight. 1 mole. Here 1 gram they taken. So that is half mole it is. Half mole of hydrogen occupy 11.2 liter. So similarly, you take the 22 grams of carbon dioxide. 22 grams of carbon dioxide will also occupy 11.2 liter at STP. So here 22 grams of carbon dioxide is nothing but half mole. Now you see here equal number of moles at STP condition contains the equal volume. That is, equal volume of all gases contain equal number of moles and molecules. If their number of moles are equal means number of molecule is also equal. Is that clear? This is what Avogadro's law, which is very, very important one. So Avogadro's law. So far we had discussed the 4 gas laws. So this based on gas laws, we'll discuss the number of problems. In the next video, I will explain the complete problems on this gas laws. I think so you have enjoyed it, and as well as you learned something new information. So complete data about gas laws I have explained. So I will explain you in the next video, that is problems on gas laws. So don't forget to watch the complete videos of Upper Chemistry classes. So please do subscribe and share with your friends. Okay, thank you. Have a nice day. Keep watching Upper Chemistry classes.